Has any of you ever faced a production stoppage due to a breakdown or failure?
So regarding the operation of the factory, yes, we've had production stoppages before, and it's really not good.
And how much does it cost?
I can't give you the exact cost. It depends on the machine, and those things are complicated to calculate. It also depends on the industry it's related to, like if it's automotive or things like that, but it can easily go up to several thousand euros.
Do you know how the crisis was managed? Do you have an example that comes to mind?
So it's more of a personal experience because I originally studied maintenance, so I was involved in that area. It puts a lot of stress on the maintenance staff, and it puts production people out of productivity. In terms of efficiency and things like that, it's not very good, and it generally doesn't create a great atmosphere.
A 1-hour production stoppage in the industry costs 220,000 euros.
That's expensive.
Stefan, can you explain to us what a predictive maintenance system is for...
When we talk about maintenance, there are several types of maintenance. Let's say reactive maintenance means, in quotes, we do nothing. We wait for the breakdown to happen, and then it's panic mode, and indeed it's a disaster. So basically, there's no maintenance. Well, there is maintenance, but we only intervene when there's a breakdown. There's no anticipation. Then there will be planned maintenance, meaning we'll say, well, every 6 months I'm going to check in a bit, and then I'll change things if I see that there are some differences. Then we will have preventive maintenance, where we analyze which products are installed and create a sort of schedule, but well adjusted based on the equipment to be able to anticipate and react to.
Like a super schedule?
Super schedule, there you go. And then there will be predictive maintenance, where it goes further, meaning we will be able to anticipate a risk of breakdown. And in this case, with the product we're going to talk about, we use artificial intelligence to achieve that. So it really allows us to order the products in advance based on the risk, have the operators and maintenance people available on time, and so on. So there's a whole environment that will really help to anticipate breakdowns.
Okay. So to get into the more technical details of this solution, we set up a data collection system, particularly with a vibration sensor. And then we send that data.
The vibration sensor, as we mentioned, uses the LoRaWAN protocol. In the industry in general, we go through a gateway, the one you mentioned. So we have the WISE-6610, the small gateway we showed earlier, which will collect the LoRaWAN data from the various vibration sensors installed on different motors. Then it connects, so it has an Ethernet port or Wi-Fi, and it can send the information to a cloud. We have a solution called WISE-IoT, which allows all this sensor information to be uploaded there. So here we're just talking about information gathering and dashboarding. So we won't really be discussing predictive maintenance as such. We'll see how the sensor works, how the motor operates, and an operator in front of it will be able to visualize that. On top of that, we can run an algorithm, which is a solution we call PHM on our end, where with some learning involved, there's a pre-learning phase that's already implemented, but then we can do a more specific learning related to the motor in question and the positioning of the sensor on that motor. It will then be able to analyze the data frames and provide predictive alerts by sending messages to different operators, doing reporting, dashboarding, and everything that goes with it.
Okay, you're talking about motors. This system allows monitoring of rotary motors. What type of motor? All types of motors.
In fact, it will be useful for motors like pumps. It can also be used in anything related to ventilation, as these are rotary motors. The simple use case is a motor that always runs at the same frequency. We put it on there and it sends the data up. Recently, we evolved the solution to include other use cases because we have factories where there are motors that start, stop, start, stop. There are others that will ramp up, meaning they'll start off slowly and then there will be an acceleration. So we see that there are variations in speed. And there, if we've trained it at a given speed using artificial intelligence, as soon as we accelerate the frequency, it will recognize that something is wrong. And for him, that will be an alert. So the system has evolved. Integral Systems worked with our R&D to develop this solution, to be able to adapt the artificial intelligence based on the speed and therefore the frequency variation of the sensor.
I just want to make a quick note because we're talking about motors in predictive maintenance. I think it would be interesting to find a study on how many motors a company has. And actually, I think the key point is right there. We can't imagine the number of motors a company has. In fact, that's the whole point of predictive maintenance. How many motors do you have in your company? Try to calculate it, those of you watching, and I think you'll be quite surprised by the number. Absolutely.
To continue, we're using the Advantech sensor, the WISE-2410.
A quick note as well, we have two versions. We have a standard version, DAFO meaning industrial, and we have a text version, which is for explosive environments. So if the client's application requires being in an environment where we need to meet those standards, this product can still be used.
And it works exactly the same way with the software, just like that. Okay, I'm going to explain a little bit about how the sensor works. I'm not an expert in vibration analysis. However, all these processes are familiar to me now through experience. So basically, the sensor measures raw data on the three axes. In the sensor, there's a chip with a controller that applies the Fourier transforms in real time on that data, and it provides us with 8 understandable indicators per axis. So what we send to the software isn't the raw vibration data, it's the calculated data after applying the Fourier transform. So we feed them into our artificial intelligence engine. It's based on an ISO standard in terms of vibration, which is standard 10.816. It's thanks to this standard that the Advantech model of artificial intelligence was able to be pre-trained. And the output model will give us two things: a health score calculated by the engine, and it will provide us with a prediction for the next 7 days regarding the engine's lifespan. Here, we're not talking about generative artificial intelligence. We're not talking about ChatGPT. It's a machine learning model that runs and gives us indicators. It takes input data, the data from the sensor, and it gives output data. There's nothing magical about it. It's just math, and it works really well. Recently, Stefan and I were able to test and validate the predictive maintenance system on a mini production line in a place called the Industrial Hive.
In Lyon, absolutely. So basically, we went with Integral System, specifically Red One, to the Industrial Hive, which is a kind of platform where different companies work and collaborate together to implement various use cases and see what current and future solutions can meet specific needs. And they have, for example, in one of the rooms, a sort of mini factory specifically set up with a rotary motor, and they've created a system to simulate breakdowns. So basically, they have a classic rotary motor, and on it they have the option to add, for example, a weight magnetically to misalign it, which causes the motor to run abnormally. That was the first test we did. So the first time we were there, we went twice, and the first time was just to check that the sensor was responding in terms of analysis and correctly capturing the change in operation, which it did. They appreciated how the system worked and its accuracy. And then we did some more tests and let it run for a while, so we could do a little troubleshooting in the meantime, so that the system could actually analyze the motor's operation when it was healthy. Then we introduced some faults, observed, and indeed we were able to anticipate and see that things were happening. After that, we didn't let it run for a full 7 days, so I don't know if it has been run again since, or if there have been other tests later.
You were on a demonstrator?
This is a demonstrator, and we have the possibility to go further. So what was done is to measure the speed of the motor, because this motor was connected to a controller with an OPC Capware server. The idea is that Capware has the information, and so from the gateway, as we said, the gateway is smart. It also has, for example, Node-RED. I believe that's the scenario we worked on, and in Node-RED we can query while we're in bus mode, so we can retrieve the speed, and from there we can run our artificial intelligence algorithm at different speeds and analyze that.
When it comes to retrieving data in bus mode, it's a bit more customized. You need to connect to a system like Capware, etc. So it takes a bit more time, and generally it involves an integrator, which is a third-party installer who goes on site and sets up the system.
Existence. It's more intrusive.
Exactly. The idea is to train the motor at different levels, so at 25% of its power, 50%, 75%, and 100%, and to change the model being used based on the reference value. So Integral Systems is successfully integrating the TCT sensor as a reference value provider into Advantech's predictive maintenance system to enable the management of much more complex use cases. So if you want, today we have the ability to monitor a motor that operates at different speeds, to provide reliable values about its health status and predict its health status using two non-intrusive sensors that cost next to nothing.
It's a major advancement, that's for sure. It's an increase in the accuracy of the data being reported. From the moment you combine two sensors with AI behind it, we have a great system that allows us to control and measure the health status of these motors.
Just to add one last quick point, the advantage of being based on LoRaWAN technology is that we see there's a Advantech product that communicates via LoRaWAN and a TCT product that also communicates via LoRaWAN, so it's completely agnostic to the hardware. And tomorrow, with this system, you need to have a leak measurement because it's a pump, so there's all the vibration measurement part, but there are risks of water leaks. You can think about the EVA sensor we were talking about earlier. You install it, and it's also on LoRaWAN. So you add that to the infrastructure, and in the same dashboard, you'll have power calculations, operating times, leak detections, along with the history as well. So LoRaWAN wirelessly allows you to aggregate information from different manufacturers.
And to evolve your installation over time without major modifications. In fact, we add a sensor, the RA1, and we integrate it, and it works.
To continue and perhaps conclude this part as well, we have made these technologies accessible to people who didn't even consider it, actually.
That's exactly it for SMEs. Small and medium-sized industrial companies that never imagined they could one day operate like a potential automotive giant with its factories. It allows for democratization. Now, with this technology, there is a huge amount of expertise. Now we need to make it known. See, everyone can use it.
So to conclude this part, and this will also be the beginning of the conclusion, I just want to highlight the fact that today we are doing a podcast in French. TCT is a French company that produces in France and which belongs to a French group. Advantech is indeed a Taiwanese company with a French branch represented today by Stefan, and so everything we do is local. We can talk with the different local players. In our language, it's definitely better, and we provide solutions. The expertise is with us, so we need to make our industry benefit from it, to the players who can take advantage of it. We don't have that barrier of product availability because everything is in France, so that was important. Well, thank you for this great discussion. I think the exchange has been very interesting, both for you and for me and for the viewers. I'll let you wrap up. So please, you can talk about the sensor, you can talk about the predictive maintenance solution, but you can discuss just about anything you want.
First of all, thank you for organizing this podcast. What's interesting for the people watching us is that, well, we are two companies, but from different companies that didn't know each other and yet have products that come into service and work well. For TCT, it's a great advantage to be able to work with Advantech solutions, highlighted by the integral system. So we remain just a manufacturer of a sensor and we won't go beyond that in the ecosystem. And I think this podcast was very interesting as it was able to show that the future of IoT is really ahead of us. There are new developments, new solutions coming in. What we discussed for SMEs and mid-sized companies is that we are focused on controlled costs. So we now have a measurement solution that is completely controlled, which is really accessible to many industries. So thank you very much for this invitation, for this exciting moment. That was short. You're welcome. There you go. And then I hope to do more of these. And thank you.
Pleasure.
Do you have a surprise?
On the same side, I wanted to thank Integral Systems for a constructive exchange with different viewpoints that indeed come together because clients in the field have similar issues, always with slight differences. And we see that products like the ones we discussed can adapt to specific needs. On the Advantech side, we really talked about data acquisition systems. And as I mentioned, we have a much broader range. So feel free to contact Integral Systems for more details on that, whether it's at the PC level or communication level, because sometimes you need to connect these devices. For example, there are industrial switches. We are still in the industrial sector and we have a whole range on that. So the idea is to be able to support you. Advantech is an international company present on all continents. If you have entities with different factories, for example, it could be the case with factories in France, factories, I don't know, in Germany, in Italy or elsewhere, even across the Atlantic. These solutions will be functional and Advantech will also be able to support you in deploying these solutions across different factories with a partnership like Integral System.
And there's a lot of stock at Integral. Don't hesitate. There is stock available. Don't hesitate, responsiveness and service. And the smile on top of that, of course. And the chocolate croissants in the morning